today's learning target was I can describe the properties of a wave. Our really important terms start with amplitude. Say it with me. Amplitude. Amplitude is the maximum distance that a wave vibrates from rest position. Our next important term is wavelength. Say it with me. Wavelength. Wavelength is the distance between the two adjacent troughs or crests, or if you have a compressional wave or a longitudinal wave, you have rarefactions or compressions. Our third term is frequency. Say it with me. Frequency. Frequency is the number of waves produced in a given amount of time, and this is expressed in hertz, which is capital H, lowercase z. Our fourth important term to describe the properties of a wave is wave speed. So say it with me, wave speed. Wave speed is the speed at which a wave travels in a given amount of time. So here's why these things are important. If a wave is coming on a beach, you want to know how big it is. Is it going to knock you over? It's amplitude, right? Also, you could think about it like a sound wave. How loud do you want to turn up your speakers? If you turn it way up, you have a big amplitude. If you turn it way down, you have a small amplitude. Wavelength and amplitude are related. So the shorter the wavelength, the higher the pitch. So if you have a sound that goes it went from low to high pitch, right? The wavelength determines actually like what kind of sound you hear or how big or how far apart the waves will be. So if there's a tsunami coming, scientists can tell you there's a tsunami coming and there's one wave right behind it and it's 200 feet behind it. So you have this much time to get away from it. Okay. For frequency, this is again the number of waves produced in a given amount of time. So I'm just going to use water waves again for that example. So frequency just means like how many waves roll up onto shore, in a minute. So maybe it's 15 waves roll up onto shore in a minute for a regular ocean pattern, okay? So what happens when the waves increase? Maybe there's 20 or 25 waves that are happening on the shore, and that means that they will erode the shore even more. If I'm not talking about beach waves or water waves, I'm talking about high frequency, which means that sounds are close together. So a low frequency, a higher frequency. Okay? So wave speed is how fast the wave is traveling. It's kind of like, a car goes a certain amount of distance in a certain amount of time. It takes you 10 minutes to get to the grocery store, 15 minutes to get to whatever, the dollar store. So wave speed, same thing, like how long till that wave gets to where it's going, okay? How fast is it actually traveling? So when you're drawing something to represent waves, these are models. So here's a small amplitude wave compared with a large amplitude wave. You can see that they're pretty close to the same distance apart, but the large amplitude wave is much higher than the small amplitude wave. You can see the resting position is this dotted line, right? So it's just a really high wave. So a small amplitude has a low energy, and it's a soft noise. A large amplitude has high energy and it's loud. Okay, so if you're talking about sound. If you're talking about water, small amplitude means the waves aren't very high, just little ripples maybe. If you're talking about a large amplitude in the water, you're talking about big waves that are going to knock you over if you stand in them or rock your boat a lot. All right, when you're looking at high frequency waves, it means that it's vibrating really, really fast. So maybe lots and lots and lots of tiny little waves or lots and lots and lots of big waves, okay? If it's a noise, it's a high pitch because it's vibrating really fast. You can actually kind of feel that. Put your hand on your throat and make a low, low, low pitch noise. Low low pitch noise is this, low frequency, and a high pitch frequency. So we're going to do it together, and you feel on your neck that this pitch is going really fast and your low frequency is going slowly. Okay, ready? So here we go. Everybody make a high pitch. Ah! Now low pitch. Ah! You can try it again. Ah! 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 All right. You can do this again at home when you're alone, and you can be quiet. And you can be loud. Okay? So this is what these waves look like if you could see them, with small amplitude, low energy, large amplitude, which is high energy, which is loud, high frequency, which is a high pitch, which vibrates really fast, and a low frequency, which is a low pitch, which vibrates slowly. Hopefully you can remember all of these properties because we're going to start measuring them.